In this video we'll go on to look at problems 17 through 22, and in each of these problems we can use the chain rule by first rewriting. So with 17 we can rewrite that as x minus 2 to the negative first power. And when we rewrite in that way, the derivative is fairly straightforward. We take the derivative of the outside, so we get negative 1, then quantity to the negative second power. We'll leave the inside alone. So the derivative of the outside, leave the inside alone, times the derivative of the inside, which is just 1 in this case, and that will leave negative 1 over x minus 2 to the second power. Next, 18, we're going to rewrite that as quantity t squared plus 3t minus 1 to the negative first power. 18, then, the derivative would be s prime of t is equal to the derivative of the outside, leave the inside alone, gives you negative quantity t squared plus 3t minus 1 to the negative second, times the derivative of the inside, and that would be 2t plus 3. So we'll have negative quantity 2t plus 3 over t squared plus 3t minus 1 to the second power. And that takes care of that. Number 19. Now 19 could be most easily simplified and rewritten by applying the exponent of 2 to both the numerator and denominator. So then that could be rewritten as t minus 3 to the negative second. If you didn't do that kind of rewriting, then you're going to have to do a power rule on the outside with a quotient rule on the inside. And so this really is going to make this a lot simpler. So f prime of t will be equal to negative 2 times t minus 3 to the negative third power times the derivative of t minus 3, which is just 1 again. And so you end up with negative 2 over t minus 3 to the third power. For number 20, that can be rewritten as 5 times t plus 3 to the negative third power. And the derivative would be y prime is equal to negative 15 times the quantity t plus 3 to the negative fourth. Then the derivative of the inside is 1 again. And that will end up as negative 15 over t plus 3 to the fourth power. Number 21 we can rewrite as x plus 2 to the negative 1/2 power. So the derivative, y prime, is equal to negative 1/2. Reduce the exponent by 1 would be negative 3/2. Leave the inside alone at x plus 2 times the derivative of x plus 2, which is just 1. And that one ends up being negative 1 over 2 times x plus 2 to the 3/2 power. Now 22 looks scary, but it's also easy to simplify because it can be rewritten as square root of 1 over square root of t squared minus 2, and square root of 1 is just 1. So this can be rewritten as the quantity t squared minus 2 to the negative 1/2 power. And the derivative, g prime of t, then, will equal negative 1/2. Subtract 1 from the exponent, giving negative 3/2. Leave the inside alone, which is t squared minus 2, times the derivative of the inside, which is 2t, and the 2's, we'll rewrite this as negative 2t over 2 times the quantity t plus 3 raised to the 3/2 power. Then the 2's will cancel, and finally leave negative t over t plus 3 to the 3/2 power. And so each of these examples here show how the original function could be rewritten either with a negative exponent, a rational exponent, or a negative rational exponent that can still make the power rule with the chain rule very straightforward. Remember, take the derivative of the outside, leave the inside alone, times the derivative of the inside, and then you are done. And it makes all of these derivatives a lot simpler than doing them using the quotient rule, the product rule, or other combinations.